Most of the real data are predominantly composed of normal observations with only a small abnormal or interesting observations, but they are most of the time of great interest. But when this happens, when we have imbalanced data problem, machine learning algorithms tend to produce high misclassification rate for the observation in the minority class. For example, I have 100 students in my class, and let's say 5 of them are not successful and 95 of them are successful. So if I ask you to classify them one way or the other, the most intelligent way of doing so is to label all of the students are successful, because when you do so, you are getting 95% accuracy. But on the other hand, when it comes to students who failed, we have 0% accuracy. So the reason is that it's quite intuitive, like we are. Machine learning algorithms tend to ignore minority class observations because they are not contributing to model accuracy as much as the measured observations in the measured class contributes. So that's why machine learning algorithms ignore them, but which creates problem because we would like to detect them. For example, fraud detection. There are many orders, calls, or transactions, but only few of them are fraudulent that they are of importance. But if they are very few, then machine learning algorithms ignore them. So what we are doing is that we propose a novel approach in order to increase the number of observations in the minority class. When we do so, let's go back to the example that I gave. If you have 5 students not successful versus 95 students who are successful, and simply speaking, machine learning algorithm classify them as successful. But what we do is we increase the number of observation in minority class by creating artificial observations. So our algorithm creates those artificial observations in a way that machine learning algorithms learn from imbalanced data better. Basically, when we manipulate the data, when we increase the number of observation in the minority class, when we have, let's say, 95 students who are not successful, but 90 of them are artificially created versus 95 successful students, so you cannot just go ahead and classify them as all of them are successful because you would get only 50% accuracy. So when we do so, what happens is that we empirically show that our methods increase the ability of the machine learning algorithms to learn from the imbalanced data set. There are many techniques in the literature proposed, but we show that our algorithms outperformed, on average, all the existing algorithms. So the result is we observe and empirically show that when you use our method in order to balance your data set, you are able to produce or develop machine learning models. They have better predictive power. So they are more accurate, more reliable.